Without packaging, today's era will not prefer a single food product or material without packaging because it provides protection. Packaging involves two basic areas, that is marketing and logistics. Packaging provides information about products. It also promotes products through attractive graphics and also attracts attention of the consumer. And also it acts as a silent salesman. Then what is logistics? So logistics is a means of ensuring that the product in it is a that is self-delivery to the ultimate in sound condition at minimum cost. There are three P's of processing, that is preservation, protection, and presentation. So now we will move toward what are the functions of packaging, why we should package the food, or what the packaging performs each function, what is the role of packaging. So we all know the main function of packaging is protection, that it provides protection from dirt, insect, dampness, and breakage. So the food material in it is get protected from natural deterioration. It also provides physical protection. That is, if we see we have the packet of oil from our hand in the on the ground from the height, no, nothing happened to that packet. It's why it's just only because of its packaging material. In the packaging material provide it from physical damage. Then safety. Safety is most important point. That is, it provides protection from the contamination from the insects, say, or microbial contamination. Then also it reduces waste reduction. If we see in market, in sabji mandis or fruit market, the product which are sold in without packaging, there we find in the period of gluts, lots of food material is get wasted. Now India is producing a lot, but the post-harvest process are the main challenges before us. How we will reduce it? Packaging is one of the way of protecting the food material that we produce. Then containment. Containment is nothing but it provide convenience in the carriage of the product from one place to another, and in stocking and in consuming. For example, if we see a new PET bottle, means polyethylene terephthalate bottle of Coke, we see that it is very easy to carry and stocking. Similarly, the bag of fruity, we are all familiar with the fruity. It provides convenience in its consumption. That is easy for handling and also for the consumer to use it. Then information we get from it, that is communication, say, or the for that packaging conveys necessary information to the consumer. The common information that package provide includes general features of the product, its ingredients, net weight, the rate. Also the packaging series act as an identification for the product. A product is packed in a special size or colored or shaped container for keeping it different from the product of competitor. So packaging also helps our industry to compete with the other industry having the same product. If your package is more attractive and giving more information or special look or identification, making it different from other, will attract your customer, and your sales will ultimately increase. So packaging plays an important role. Then utility of use. The convenience packaging have been devised for different types of foods like liquid foods, solid foods, semi-solid foods. Then promotion. Promotion is an important and inevitable say function of packaging, that it use of attractive colors or logos, symbols, say different types of captions. They say like we see in the Maggie, right? 2 minutes noodles. These are some of the captions in the packaging material, which also attracts the consumers. So these are some of the functions of packaging. So now we will move to our subject knowledge, that on which the intelligent packaging is based. So to understand intelligent packaging, we have to go through the basics. So first of all, we see that what is nanoscience. What is the role of nanotechnology in the field of intelligent packaging and how it works. So, nanoscience is science concerned with the study of novel phenomena and properties of materials that occur at extremely small length scale. It means it is the study of phenomena and manipulation of material at atomic, molecular, and micromolecular scale. We all know that the products at the nanoscale, say there is a scale we know from 0 to 100. This is also a scale. Likewise, below 100, there are different scale like nanometer, micrometer. So nanoscience is based on the material which are in the atomic size of it. So now in nanoscience we use materials. So every material has different properties at their larger scale and at their smaller scale. Like gold, if we take gold or silver material, if the gold or silver material, if we use it in large scale, then it has different properties. And if we make it nanoparticle, then it acts as a different. For example, silver acts as an antimicrobial agent when it is in its nanoscale. Nanotechnology is the application of nanoscale science, engineering technology to produce a novel material and device. It involves the characterization, fabrication, or manipulation of structured devices or material that have at least one dimension approximately 200 nanometer in its length. From the next coming slide, you will get familiar with what is nanomaterial, what is its size, and you will find easy to learn it. Now, what is nanomaterial? The component having its approximate dimension of 1 to 100 nanometer in length are known as nanomaterial. There are three types of nanomaterial, that is biological, inorganic, and organic. In the picture at the right hand shows some of the inorganic nanoparticles and some of the organic nanoparticles. So the scale what I am talking about is this. In this scale, we find as the this plate the end has the highest dimension. That is from this we find that the highest scale found to this creature, that is 10 to the power minus 3. Are you able to see my cursor? Hello, ma. Participants can raise their hand if they are able to see the cursor. Okay, fine. I got the answer. So this is the highest in this case if we consider this scale for depicting it. And if we put the elephant or some ball shape or some or different ladder, then this will be the smallest place. This will get the smallest place. So in nanoscale, we find small will be the nanoparticles. So they range from 10 to the power minus 7 to 10 to the power minus 10. We find that there is the nanoscale. So this should be the dimension of our nanoparticle. In reality, we find that the ant is approximately 5 mm in length and the red blood cells are approximately 5 micrometer in dimension. That is 1000 times it is smaller. So nanomaterial is smaller than that red blood cells also. This is the pictorial view that you will get to know how small the nanoscale is. And which of the following, like some DNA strands, say antibodies, proteins, oligonucleotides, comes in the nanoscale. So now we move toward the nanofoods or say nanotechnology. There are wide scope in the field of agriculture, processing, product and nutrition. So if we find in the sector of agriculture, the pesticides or herbicides we are now using are getting banned due to their hazard effects on the body. But if we have to carry out conservation agriculture, say the conservation agriculture can't be carried out without using herbicides, say, because there are the lots of weed infestation in that. So to prevent it, now scientists are using the nanotechnology to make the different new pesticides, herbicides, and they are targeted toward the genetic engineering and also preservations, agri-chemicals, then sensors to monitor the soil condition. That only by putting a small sensor in the soil you come to know about the soil conditions of that. So this much innovations are going on, and there is a huge scope of nanotechnology in agriculture also. If we move towards processing, then we find that there are many food material which are heat sensitive and they lost their aromas, flavors due to heat treatment. So for preserving it, we can't use the thermal treatment for them. So many of the technologies like nano encapsulations, like they capture the aroma and flavors in the capsule, and it is preserved during its storage conditions, or different preservation methods like gelations and viscofying agents are also prepared with the help of nanotechnology. Then nano emulsions, anti-caking. And then for sanitization, different types of nanomaterials are used. Like I said in earlier slide, that silver molecules, silver nanoparticles act as an antimicrobial, and also gold nanoparticles are extracted from the waste of our household vegetables, that we cut vegetables and use for making different types of sabzis. And the leftover of that vegetable is used to extract the gold and silver nanoparticles, and that silver and gold nanoparticles are used to make such kind of products which value adds its quality and also get good returns to the producer or industry. In case of products, so UV protection, that these products are mainly deal with the packaging section, like the product is protected from the UV lights, antimicrobial conditions and abuse monitors. Then high barrier plastics are made with the help of nanoparticles. Then security and anti-counterfeiting contaminant sensor. Then nutraceuticals, nutrient delivery, minerals and vitamins fortification. In the case of nutrition, we say drinking water purification. Then sensor characteristics of supplements. These are some of the applications of nanofood, say, or nanotechnology in different fields. So now we will move towards our main point, that is packaging. The most active area of food nanoscience research and its development is packaging. Without packaging, your food do not add the value in the market. The global nano-enable food and beverages packaging market was 4.13 billion in US dollar. That is 291.89 billions in rupees in 2008, and now it has been projected to grow in 2014 and representing an annual growth of 11.65%. This is the statistics of 2014, but now if we see the scenario, it has been increased much more. Nano-enabled packaging in the food and beverage market segment in up to 2014 is depicted in this table. That how much amount of active packaging, intelligent packaging, and controlled release packaging, that is control atmospheric storage, we use. That CAP we have learned in our courses, NAP, CAP. These are the preservation methods. So how much market is in was there in this years is depicted in this table. So from the study, it was found that in the earlier there was more use of active packaging and lesser of intelligent packaging due to some constraints like a higher price, or say it is costlier due to sensors embedded in it. But as we are moving towards 2020, say, so there is increase in intelligent packaging from the percentage of 25 to 34. So people are moving towards the smarter way, and they are approaching towards the packaging which communicates with them very easily, and they found easy to find that this product is doing. We can see from the survey that what people are consuming. And to be an entrepreneur, it is very important to do market survey for your industry. If any of the industry, if you want to establish, you have to first do market survey. If there is demand, if there is no demand and you are putting your industry, then you will be in loss. So it is also important to know where the market strategy, what is the consumers planning towards buying the things. So in packaging section, we see that nanomaterials have different applications in intelligent packaging, say polymer, nanocomposite, then surface biocides, and active packaging. Active packaging also involves some of the nanotechnologies aspects in it, but at the lesser strength. Intelligent or smart packaging incorporates the nanosensors to monitor the condition of food. This is an important part for about intelligent packaging. Then, if we move towards nanocomposite, then these are the plastic polymers which are incorporated with the nanomaterial with antimicrobial properties. Like silicon, carbon nanocomposites are there, already prepared by the scientists, which have been used in the polymer for packaging material. Then, improved nanocomposite like polymer incorporating nanomaterial to improve flexibility, durability, temperature or moisture stability barriers. So, these are some of the packaging ways in which the nanotechnology takes part. So what are the advantages of it to use this? It is an innovation. We all know that this type of communication facilities of the packaging had been growing, emerging in the market. Also, it is light in weight, better protection and preservation to the food, and improved performance of bio-based material. So, intelligent packaging. Now, our main topic starts. That intelligent packaging is incorporation of nanosensor to monitor and report on the condition of food. That is how this package shows us on the package. They communicate with the consumer by showing different colors on it. In the picture you are seeing on the right side of the bottom, there is a packed food in which the label is attached. On this label, there are some of the sensors embedded in it, which changes its colors with increase in its time, and it shows that it is able to be consumed or not. ये आप खा सकते हो कि नहीं, ये आपको वो पैकेट खुद होके बताएगा. कैसे बताएगा? तो वो अपने अपने पैकेट के ऊपर जो सेंसर लगाया है, वो सेंसर का कलर धीरे धीरे चेंज होता जाएगा. एंड द कलर इंडिकेशंस, उसमें कलर के इंडिकेशन भी दिया देते हैं. जैसे ग्रीन है तो इट इज सेफ फॉर कंजम्पशन. इफ इज गोइंग टुवर्ड्स रेड, देन इट सेज प्लीज कंज्यूम मी अर्लियर, or I will get deteriorate. And if it changes totally to black, then it is destroyed food, or say deteriorated food, which is not good for consumption. So they are able to respond environmental changes inside the package, like temperature, humidity, level of oxygen exposure. So how this is done, how the package is doing this is the degradation of the product or microbial contamination. Also, it gives the history of storage and period of storage, that how long it will be safe to store. So, smart or intelligent packaging uses nanomaterial for sensing biochemical or microbial changes in the food. For example, detecting specific pathogens developing in the food or specific gases from spoilage. So, these so-called nanosensors are able to respond to external stimuli change in order to communicate, inform, and identify the product with the aim to assure its quality and safety. The recent development for polymer nanomaterial for smart food packaging includes spoilage indicator, oxygen indicator, product identification, traceability. Now, these are some of the points included in the third point, that oxygen indicator. लाइक अभी कोई पैकेट है, समझो फ्रेश कट फ्रूट्स एंड वेजिटेबल का पैकेट है, फ्रोजन पैकेट है जो फ्रीज करके रखे हुआ है, और समझो वो जनवरी मंथ में हमने पैक किया है. तो उसमें जो रेस्पिरेशन की वजह से या तो फिर उसमें जो ऑक्सीजन कंटेंट है वो बढ़ रहा है, या इट इज स्टिल गुड टू कंज्यूम. दिस इज इंडिकेटेड बाय द ऑक्सीजन इंडिकेटर. और is it getting spoilage? And see, these from our naked eye. But these package communicators and use information about such a nice thing that we come to know from package itself, that it is good or not, and what to buy and what to not. If we bring the fruits and cut fruit and vegetable, this is not likely to happen in the rural area, but in the urban areas mostly people prefer to pack cut fresh fruits and vegetable. And this is also a upcoming industry, or say minimally these are also known as minimally processed foods, that there are freezers industries use the fresh fruits and vegetables, cut them and pack them and store in the freezer and preserve it in frozen condition, and they stay in the markets and people consume it. But from harvesting to the consumer at the time at which it consume, it is not so that आज जैसे हम लोग रूरल एरियाज में देखते हैं कि फार्मर सब्जी ग्रो करता है, दूसरे दिन मार्केट में लाता है, हम मार्केट में से खरीदते हैं और उसे कंज्यूम करते हैं. ये सब अर्बन एरियाज में नहीं होता है, क्योंकि रूरल एरिया से अर्बन एरिया में फूड मटेरियल ट्रांसपोर्ट होता है. इट कम्स टू इंडस्ट्री एंड देन इंडस्ट्री प्रोसेस इट एंड देन इट कम्स टू मार्केट. सो इट टेक्स नियर 2 to 3 days in this process, and people are consuming it after the 4th day of its production. So there are many chances of contamination, or if during packaging, say the hygienic practices are not applied, or the industry do not follow the FSSAI rules, or do not imply the good manufacturing practices like GMP and HACCP practices during its manufacture, then there are many chances that the food in that package will get damaged. But we can't see it from the naked eye. We see it as fresh as it is stored in freezer, but there should be chances, there may be chances of getting spoiled due to some microorganism. This spoilage is indicated with the help of intelligent packaging, with the help of nanosensors embedded in it. So this is the most important packaging technology which will grow in near future due to this COVID-19. So these are some of the applications of nano technology. Intelligent packaging, that nanosensors are being used, freshness and spoilage indicator are there. It detects the gases that due to respiration there is an increasing in certain kind of gases or not, ethylene is increased or not, if there is overlapping or not, then product identification and anti-counterfeiting. Or also it gives active tags and traceability. Traceability is now also in the material that we see the barcode in the packet food. And there are linings in black linings. If these are the barcode we say in the packet, it gives the information about the at which time it is produced, from which company, and date and time are there encoded in the form of codes in that barcode. So by tracing that barcode, we find the exact location and exact place point at which it is packed, which workers have been worked at that time. All the information we get from this tag and traceability. If some food gets spoiled, or if food poison gets occurred in the consumer section, say if a product of a company is consumed by some customer and he got food poisoning, or say if the tag project is if that food is not good, so from that tags and traceability facility, it is traced that from in which condition that food is made, and other further actions are taken. So nanosensors. Packaging equipped with nanosensor is also designed to track either the internal or external condition, as I explained earlier, of food products, pellets and containers throughout the supply chain. Supply chain means it is the chain from harvesting to the end product which the consumer consumes. That it involves harvesting, then pre-cooling, then transportation, then storage, then processing, then packaging, then again transportation, detailing, and when it comes to the consumer. This whole chain is known as the supply chain. Nanosensor in plastic packaging can detect gases given off by the food. that is I said during food respires after harvesting. Each fruit, when each fruit say we pluck from the tree, it starts respiring from that point. So when it gets spoiled, the packaging itself changes color to alerts you. Nanosensors are able to respond to environmental changes, that is temperature or humidity in storage room, level of oxygen exposure, or degradation product of microbial contamination. So in this figure you see this is the intelligent packaging in which the fruit is packed, and there are shown three labels like crisp, firm, and juicy. So if it is light yellow, then it is good, and you can store it and consume also. Firm, you can consume it readily, and it turns to red, then it is not suitable for your consumption. In this way, nanotechnology helps to detect certain chemical compounds, pathogens, and toxins in the food. It eliminates the need for the inaccurate experimentations. Also providing real-time status of the food freshness. That means if at this time if you are taking that food, you get to know that it is fresh or not, or it is stale, or got damage due to microbe, some other things. Hello, is my voice
Yes,
is reaching to
yes,
you?
yes.
Because I have got a dialog box that you are sign out because of currently signing to other device. Okay, so now we move to our lecture. This is the slide in which as I told earlier that this we find that how fresh the fruit is. Now, freshness and spoilage indicator. Based on applied studies of surface properties of material, several types of gas sensors have been developed, which translate chemical interaction between particle on the surface into a response signal. So, these sensors, what they do, the mechanism behind it is the chemical reaction. They sense it and they encoded it. This is suppose, as we know, we input data in our computer, but computer didn't know our language. Similarly, we didn't know the property of food that we are going to consume it. So, this package acts as a computer for us. As we input the data in the computer, that there is coding, then it is decoded, and in the monitor we see that what we had typed. Similarly, in case of food, we say this we can't judge that food that it is good or not. So the what chemical interaction has been done. This package encodes that all information and displayed on the package to the consumer that it is good or not. Food spoilage is caused by microorganisms whose metabolism produce gases which can be detected by conducting polymer, nanocomposite, or metal oxide, which can be used for quantification or identification of microorganisms based on their gas emission, as well as for food freshness detection. So these are some of the freshness sensor for smart packaging based on nanofiber polyethylene. This study is done by the Kurtzi and Kosmany in 2012. In this we find that these are in this we are given the signs that this is the fresh one. This is are you able to see cursor? Like this is fresh one, this is still fresh, and this is not fresh. That it is not used for consumption. Similarly, this label are coded on the packaging material in which the food is packed. So we see difference in it. Like see here there is green color, that is it is fresh, and now. So you find it left, there is a reference color for detection of it, and it is also given in the package. So you can easily find this. So freshness indicator provide real-time information to the producer, retailer, consumer on the actual product quality during storage and distribution. Coating of 1 to 10 nanometer thick of silver or copper is during on the plastic film or paper is also useful for it. Upon reacting with the sulfide volatiles, produce a fresh meat which undergoes spoilage. The thin coating turns into distinctive darker, then it changes its color. There are 3 bacteria which are more harmful to us and which can these bacteria can be detected by the sensors like Bacillus cereus, Vibrio pharmacopoeia, and then Salmonella species. These are the most food possible to us, and it causes disease or fatal if consumed in more quantity. An electronic term we are familiar with is incorporated with this food packaging and have and it also developed. The device consists of an array of nanosensors extremely sensitive to gases released by spoiling microorganisms produce a color change which indicate whether the food is deteriorated or not. Now detection of gases. How gases are detected. Now we have seen freshness detection. How freshness is detected. Now we will move towards how the gases are detected. Then sensors of oxygen. How oxygen is sensed. Oxygen allows aerobic microorganisms to grow during food storage. As we know, the aerobic microorganism use the oxygen and grows fastly and damage the food. We say there is oxidation process in it. There has been an increased interest to develop non-toxic and irreversible oxygen sensors to assure oxygen absence in the oxygen-free food packaging system, such as packaging under vacuum or nitrogen. As we know that our chips pockets, we see that there in that pocket the nitrogen flushing is done to prevent the oxygen to enter in it. Such type of practices have been done, but still we have to move forward from this because sometimes we find that we consume that chips, though there is nitrogen flush, the air we look back in a very fresh condition, but when we consume that chips, we find it as a sour or something bitter taste. Sometimes we consume such type of chips. So what we find that we lose our money also, and we didn't get anything to consume. And if someone consumed it and get ill, then this will also create a different problem. So an UV activated colorimetric oxygen indicator using UVA light have been developed, which uses nanoparticle of TiO2 to photosynthesize the reduction of methylene blue by tetraethylamine in the polymer encapsulation medium. So these packaging material help us to save our money as well as our health. This detector gradually changes color in response to even minute quantities of oxygen. This type of UV activated indicator are useful for preventing premature activation of oxygen measurement, since the indicator can be activated in package after sealing as long as the package is transported to UV radiation. Moreover, this indicator can be reused as long as the sacrificial electron donor is depleted. Okay, this is some experiment done as we see in this slide with the indicator dye. This packaging is fresh. These are ABCD, and these are 4 pictures in which we find different study that you easily find that whether it is fresh or not. Then package A. So the package A is freshly sealed and both indicators are blue. Okay. Then the indicator immediately after activation with UVA light after a few minutes. The indicator outside the package return to a blue color, whereas the indicator in an oxygen-free atmosphere remain white. That is, you see slightly blue color is occurring on the outer side and in the inner side where the oxygen is not present. Oxygen is present in the atmosphere. We can't remove it from the atmosphere. So if we have packed food and there is no oxygen, and so we find that the zero oxygen content methylene blue dye sensor is still white, and the outer methylene blue sensor is going to turn blue as it is coming in the contact with light. Until this, then we see 6 C number picture. This C picture here we see slight blue is going on now in C. Until the package is open, in which case the influx of oxygen causes it into change the black to blue. That it is still white, that it shows that there is no oxygen in the package. Now this system could be used to easily and non-invasively detect the presence of leak in the every package immediately after production and at the retail site. Now what does it means that अगर आपने कोई पैकेट पैक किया है जो फ्री फ्रॉम ऑक्सीजन है, अब उस वो पैकेट के अंदर ऑक्सीजन गया कि नहीं हमें कैसे पता चलेगा? तो ये जो नैनो मिथिलेन ब्लू इंडिकेटर डाल का जो सेंसर है जो पैकेट मटेरियल में लगा हुआ रहता है, अगर उसमें थोड़ा भी लीकेज रहा तो उसमें ऑक्सीजन एंटर करेगा, ऑक्सीजन के साथ इसकी रिएक्शन होगी और इट विल चेंज इनटू ब्लू कलर एंड यू विल इजीली फाइंड दैट देयर इज ऑक्सीजन इन इट एंड द प्रोडक्ट इज स्टार्टेड टू get deteriorated and it is unsafe for use. So the leakage which we can't detect from our naked eye can be detected by with the help of this sensor. This is many example of, there are many examples. This is one of which I had explained you. So next we move toward sensor for moisture detection. Say moisture in this package, so it deteriorates. We know that fruits and vegetables have high moisture content, and their shelf life is low because of the high moisture content, because the products start deterioration with, due to moisture in it. Thus, the detection of humidity will provide an identification on integrity of the package and reflect quality and safety of the food. Nanoparticle dispersed in the tensile film. Moisture sensors which utilize carbon-coated copper nanoparticle dispersed in the polymer matrix, and it shows us whether there is moisture present or not. Then CO2 sensor, a non-invasive method of making measuring of CO2 content in the MEP, that is modified atmospheric packaging material, have also been devised and is based upon lifetime analysis of luminescent dye standardized by the fluorophore encapsulated polymer nanogrid. This CO2 sensors has a detection range of 0.8 to 100%, a resolution of 1%, and only 0.6% across the sensitivity with the molecular oxygen. Then product identification and anti-counter feeding. Some smart packaging have also been developed to be used as tracking device. As I told earlier, that barcode is embedded in the packaging material for food safety and to avoid counterfeit. Biomedicals have developed a multi-detection test, that is food expert, for the nano surveillance response to food scare. The nanotech company are developing nano-based tracking technologies include an indigestible biosilicon which could be placed in food for monitoring purpose and pathogen detection, but could be also eaten by the consumer. That is, it is safe for eatable packaging. So these are some of the things. A United States company has also developed many nano sensors, barcoded sensors for use, which is used for tracing. Commercially available nano barcodes manufactured by electroplating inert metals such as gold, nickel, platinum, or silver into templates that define the particle diameter and then release the resulting strip nanorods from the templates. So this in the figure you see these chips that there is encoded things which identify and use for the traceability, like radio frequency identification. At the bottom of the slide you see the picture of that chip. The tags are electronic based information based system that use radio frequency to transfer data from a tag attached to the object and to trace and identify the object automatically. It has a longer reading range also, and it works under extreme temperature and different pressure. It can be detected at distance of more than 100 meters, and many tags can be read simultaneously. Nanotechnology is also enabling sensor packaging to incorporate such chips or radio frequency identification tags. The nano-enabled radio frequency identification tags are much smaller, flexible, and can be printed on thin level also. So this increases the tag versatility and also enables much cheaper production. Now, safety issue. What are the safety issues in using such type of nano sensors based on different nanoparticles? Because safety is first for us. In terms of consumer safety, it is important to evaluate the potential migration of packaging constituent in the food. Packaging material which you are using to pack the food, which is directly to be consumed by the consumer. So it is very necessary to know that some particles are getting migrated in food or not, or they are having some reaction with the packaging material. It is an important factor to make the packaging material. Also to assess their potential hazard for the risk assessment. So in Europe, the legislation currently applied an overall migration limit of 10 mg constituent per DM to surface area to all substances that can migrate from food contact material to the food stuff. So this is their concept. Similarly, FSSAI has also put up different packaging laws and rules and regulations that how much quantity is restricted for this type of migrations of things. Silver migrated into food stimulant, and that acidic food presented the highest level of migration. So it is found that by using silver nanoparticles, silver get easily migrated in the food. So silver is not generally used as a nanoparticle for packaging material. So new bio-based nanomaterial is going used, like there is huge scope in research also to design the bio-based nanoparticle. So, safe and successful implementation of nano packaging application needs to fulfill these three regulations. That first, environmental regulation, that it should not harm the environment. That is, after using the material from that package, the package should not make the incineration, say, or say pollution in the environment. This is one of the environmental regulations you should follow. Then, product put at different food safety regulations, like there are BRCs and different. If you have to export the food, there are different types of standards. For that, they had put at the regulations and rules that how much quantity should be used, and all that standards are already given in food legislation. Then chemical safety regulation, that it should not react with the food or create another harmful substance which will be hazardous for the human, is also an important factor. So, uncertainties in consumer safety and environmental safety. Lack of understanding and how to evaluate the potential hazard of nanomaterial by oral route is one of the major things. Then lack of tools to use to estimate exposure. Then possibility. Hello. Hello. Hello.
Oh,
Sorry for the interruption. Are you getting my voice? Okay, participants have raised their hand. I think my voice is audible. So we will move next. Possibility that high surface area and active surface chemistry of some nanomaterial could give rise to unwanted chemical reactions. So this is also one of the uncertainty. Then lack of understanding on the impact of nanomaterial in waste disposal system. So environmental health and safety is some of the factors which can create uncertainties in it. But in case of safety, we have to spread the awareness among the consumers. And now I don't think there will be need, because due to COVID-19, all are get aware about their health safety, and they know how which food should be consumed and which should be not. So it will not require much efforts to market this type of packaging material. So now to the conclusion, we will move. Nanomaterials offer some exciting benefits to the food industry, including better material for food packaging and also safer food on supermarket shelves that have lower incidence of contamination with chemical additives and potentially life-threatening microorganisms. Food nanotechnology is still young, and the future of this exciting field is still largely uncertain. And here is the scope for us to make it more popular, regardless of how application of nanotechnology in the food sector are ultimately marketed, governed, and prescribed by the public. It seems clear that manipulation of matter and unforeseen products. We must continue to be hardworking against the potential danger and ethical questions that the use of these new technologies will pose, and the successful and safe implementation of this application will require constant dialogue between the scientists and companies who invent them and the consumer who purchase them. If we succeeded in this venture, then the benefit of nanotechnology will play an important role in making this world food supply healthier, safer, and more plentiful. So now we will move to the market segment. That what are the possibilities in agriculture business? Then how it will help you to put it in the business. Nano, there are very functional food packaging, as I told you about intelligent packaging, that it is a Tata filter salesman. We say in our day-to-day life that it is a salesman which do not talk in the verbal words, but it talk with its appearance to us. So it is an exclusively wonderful field to get it into and to make more innovations in that. Nano encapsulations, nano formulated agrochemicals, aquaculture. These fields have possibilities in the agri business. Then trains that food geared lifestyle is there. Now everybody want the like most of our young generation are on the hand of the fast food. So food is getting more geared in the lifestyle. So to preserve this food and how to make it healthier, it is one of the important prospects before us to how to convert it into a successful business. Then emergence of eco-food retail chains, strong focus on the use of wireless nanosensors in farming, emergence of disruptive innovations. Then what are the strategies for adaptation? Like collaborative alliance, then regional innovation cluster fund, then research and development value additions. Such strategies should be adapted. Then growth, we see that it is expected in in developed country already this type of packaging materials have been used, but it is now our turn to how to make it in cost friendly, say, or consumer friendly and also industry friendly, to make it very viable in this. So if we come forward to do something in this field, then there is lots of opportunities, and you can get more income through it, because that this from this situation after, like after COVID, say, or which we are dealing, that people are mostly consuming the packed food, and they are more getting health conscious toward it, that whether it is infected or not, it is safe or not. So such kind of packaging will help you to emerge in the market, and you will get a lots of response from consumer also, because if they find by only taking that product in their hand that it is safe or not, so it will be more friendly to them, and they will prefer your product, and the industry will also contact you for such packaging material which you will produce in your factory, and consequently the chain will build up, and the industry will go on, and you will get a lot of returns from it. So this is an emerging technology for you people. These are some of the reference which I have used to